A heartfelt thank you to each and every one of you present here. It was an honor to have you with us today. Now we are going to start with our next session, from docking to recovery in orbit servicing and space logistics. As the space economy expands, servicing, refueling, relocation, life extension, debris removal and orbital logistics are emerging as critical capabilities for the future. This session explores how these technologies can reduce replacement costs, protect high-value missions, and unlock one of the next major commercial markets in space. To chair this important discussion, it's my privilege to invite on stage Shri S. Gowrimani, Associate Project Director, Bharatiya Antariksh Station. I welcome you, sir, on the stage. A huge round of applause, ladies and gentlemen. We also warmly welcome our distinguished speakers, Dr. Chiranjeevi, Phanindra, founder, Cosmoserve, Mr. Naresh, Kannan, Business Development Lead, OrbitAID, Aerospace, Mr. J. Panchal, founder, Aule Space, Captain Abhijeet, Bhutey, founder, Inbound Aerospace, Dr. Aditya Baraskar, Senior Scientist and Global Business Lead, Orbit Lasers. It's an esteemed honor to have you with us today. Now I hand over the stage to the reputed chair and the esteemed panelists. Thank you.
Good morning all. Thank you for the invite. Thank you to ISE 2026. Being part of the BAS project, Bharatiya Antariksh Station project, I am happy to represent here the BAS project. And BAS, I'll just give an introduction of the BAS project, and then I'll go to all my panelists, and then I'll tell you what are all the new developments which is required for the BAS project, and how all these participants can involve in these activities to complete it, that we can discuss. First, this BAS station, it has 5 modules. That's the base module, core module, science module, lab module, and the common berthing module. This is the 5 modules that is called as module 1 to 5, BAS 1 to 5. BAS 1 is like a test bed. That's first it will be launched and to study the environmental and then the scientific and the payload capabilities of the system. That is, a BAS 1 is the lab module. It's like an experiment module which will have a non-regenerable ECLSS, that's the environmental control life support systems. And then BAS 2, it will be having the partially regenerable ECLSS systems, that is for the human habitable requirement, that is one of the major requirement. And then BAS 3, 4, 5, which completes the BAS station. The main requirement for this completion is the docking and then refueling, that is refueling through the docking port. And then to have a sustainable base station, we should have this space station requirement, we should have refueling and then servicing, cargo missions, and every 6 months, once the station is established, we should have a cargo mission and the crew mission for the every 6 months. So it's a continuous project. It's not like a satellite project. And if you see the base station, our space station development, all the technologies required, all are new, which ISRO has already not part of it. Only we have made satellite technologies. Now for the space station technologies, which includes docking, berthing systems to transfer cargo, and the ECLSS systems for the habitable requirement, and the microgravity experiments, all systems are new. And mainly here, we should have a replaceable electronics modules and replaceable systems to have a sustainable. Once the station is established, at least the station has to work for 20 years. So to have a sustainable thing, this cargo, refueling, all these technologies are must. Now let us hear from our Abhijeet?
Uh, a very good afternoon to everyone, and thank you, ma'am, for setting the context. So I represent Inbound Aerospace. Inbound Aerospace is, I think the audience is quite similar to the previous panel, something on the lines of Andura X. What we are working on is to increase the access to space. For the last 60 years, humanity has been talking about access to space. We've reached there, we've gotten over there. Now it's about activities in space, and that's exactly what we're trying to do, where space logistics becomes the next infrastructure layer to unlock the new space economy, and that's where Inbound Aerospace is developing their hardware. In simple terms, it is recoverable, autonomous, and a reusable spacecraft, all that the previous panel was also discussing, and that's the technology where we want to build, and of course support our subsequent national missions, in the sense the Gaganyaan mission as well as the Bharatiya Antariksh station.
Okay.
Yeah. Hello everyone. Thank you for having me here, ma'am. And maybe I think the first thing which is itching me is we didn't have a good enough applause for ma'am here. So can we please give a round of applause for ma'am here? Um, you know, because of ma'am and her team, one of us would be in space in an Indian-made space station. I don't know if everyone here feels how exciting that is, but it really gives me and our team at Aule goosebumps. Maybe I'll share a bit about us as well. We are developing in-orbit servicing capabilities, satellites which can go close and dock to a satellite in space. This can be for inspecting the satellite, taking images of it from a close-up distance, or going and docking to it to be able to solve for the fuel depletion or fix things on the satellite. That is a bit about us. We are recently funded for a pre-seed. We are based in Bangalore and have taken our technology to TRL-6. What we are trying to do in the next year is dock two satellites in a non-cooperative manner, which has not done by ISR also so far. A satellite which is not designed to be serviced is going to be approached by one of our satellites, and we plan to dock to it. How this helps is it will start off the on-orbit servicing economy as a whole. As of today, like there are satellites worth over $100 billion in the geo orbit, which will run out of fuel and stop functioning. What we're trying is building a life extension vehicle and giving these satellites a second life so that they can keep staying operational, and fundamentally changing how satellites are being used. So far it was like whenever a small component fails or satellite runs out of fuel, it is thrown away, but we're trying to change that economy towards a more involved and active economy where we are servicing assets in space and opening a broader in-space economy using the space robotics stack that we built at the core. Happy to be here and be useful to the audience with some information as we speak ahead. Thank you.
Actually, Chiranjeevi was our part of our team before he came and started this Cosmoserve. He has done a lot of protection mechanisms which is required, like MMOD protection and research which is required for the Bharatiya Antariksh station making. Whatever he has made the analysis based on that only. Now we are going ahead with the MMOD protection which is required for the BAS-1.
Thank you, ma'am, for that introduction. At Cosmoserve, we are building solutions for the space debris problem. The dual spacecraft which we are building, including a robotic spacecraft that goes to space, physically capture a dead satellite in space and then pull it down at 10x lower cost compared to the current solutions available in the market. Last year, same time, ISC was my first platform where I spoke as a panelist, and it was coming back for me to this same panel. That time the company was not even registered. So thanks to SIA-INDIA for believing the potential of Cosmoserve space and giving an opportunity to speak in a panel before the company not being registered. Like ma'am said, I was part of the Gaganyaan program, was part of different other programs like RLV. Sir was sitting here. I was building the aerothermal structures and then doing the aerothermal tests of hot structures for RLV, along with Deependran sir, you might be remembering me. Yeah. So like ma'am said, this human spaceflight mission and Gaganyaan and the Bharatiya Antariksh station are not just new to India, not just new to ISRO, but new to India as well. Because we need to create a good environment, like Earth-like environment in space, environment control life support system, and micrometeoroid impacts are not very much concerned for satellites, but these are very much important for the human spaceflight mission because the life is at stake. So we need to build all these systems. That's how I got into these systems, understood how other countries are developing, and then I thought we need to build some new systems, innovative systems in India to serve for the nation, not just the nation, for the world. As a humanity, we need to serve the humanity. That's how we started this program.
Hello everyone, thank you for this invitation and thank you ma'am for talking about all the things which we require. And I'm really excited about how the India is developing for in-orbit service, ISAM, debris removal markets. I remember Jay, when we was talking in like 2022, we just met, he was coming to Tokyo and saying that, brother, I want to know about how to start a company in orbit service. And I said that, okay, let's meet on the Haneda airport. And we talked a lot. And he decided, I'll wait for a few years, I learn, and then I come back. And he did it. It's very good how I see Indian new engineers are developing the new startups. From this, what I do, first of all about me, my name is Dr. Aditya Baraskar. I'm a founding member of Orbital Lasers. It's a Japan-based venture startup. We develop space lasers. So we do not do communication, but we use our laser for stopping uncontrolled target. So if it's a target is moving 100 RPM, which is very difficult to capture from a robotics arms or docking or servicing, we shoot laser to the target, ablate them, and stop the rotation so it can be easily captured using a chopstick. So that's what we build. Also we building Earth observation satellites. Apart from these orbital lasers, I'm also investor. So I do part-time investment in a few startups, and I'm very happily doing this for the Indian ecosystem. Few of companies which are developing very good technology in India, and I'm looking towards to develop more ecosystems where we develop. And this Cosmoserve, J company, and the OrbitAID and the InSpace City, they are doing very, very beautiful job to develop the nation, not on the ground, but in the space, and bringing India once back to the outside the countryside and making a global presence. Thank you.
Thank you very much, everyone. So, I'm Naresh, Kannan. I represent a company called OrbitAID. Ma'am, whatever modules you've said is required for BAS, I'm happy to say that we have done a lot of India's first. We have conducted 2 microgravity experiments on a parabolic flight to demonstrate refueling RPO, and we were also India's first company and India's first mission to demonstrate refueling, on-orbit refueling. And apart from it, we also have India's largest private RPOD facility based out of Bangalore. And we are also launching 2 satellites by the end of this year to demonstrate rendezvous proximity operations and docking, similar to a variant of SpaceX. And we also got support from the government of Tamil Nadu and the government of India through financial support to develop life extension solutions for satellites. So apart from a company, what we are aiming for, what our ambition is to develop an orbital infrastructure layer in space so that the number of satellites that are going to launch, we are able to sustain their presence and not just waste their potential by deorbiting. So we want to open up the space infrastructure similar to how all the infrastructure on Earth works. So, yeah.
Thank you, Naresh. This really refueling is one of the very most important requirement for the sustainable space station operations. Now, what I want to tell is each of the participant how they are relevant to space station development. And already, Muthupandian sir already has told that without this industry participation, we cannot develop all the 5 modules, launch in time, and develop the Indian space station particularly. Even though these companies are involved in commercially viable requirements, also taking care of national needs is one of the most important requirement. So now and if you see in space station development, all systems are almost new, including the avionics, which needs to be replaced. For 20 years, any avionics to work, you need a replacement. So, if I list the number of systems which needs to be developed newly, almost 90% of the systems are new. That means technologically it is new. I'll list down some of the things. That is the docking. Even though ISRO has already demonstrated docking, that docking directly we need not apply to crew module docking to space station, or to build the space station module to module docking also. So wherever these companies who are already involved in docking, those technologies also can be used to develop not only ISRO's algorithm and ISRO's technology, even the new developments who are doing, that can be one of the development for these technologies. And next is the ECLSS, that is Environmental Control Life Support Systems, which is required for the human to stay. That is, you have to make the environment habitable for the human requirement. These requirements also is there for the ECLSS. I am not telling only to the participants, even the other people who are interested in that, they can also contribute to this requirement. And the PHMS, which is nothing but the personal hygiene management systems, which is, I think, only Russians has developed now. Now India is already developing. Our HSFC team, part of ISRO, they are already developing these systems. Now even in ISS, this PHMS, which is developed by Russians, are only used. So those development also is one of the important development for our own national space station requirement. These are also new developments which is required. And then berthing mechanism, which is once the station is established, to transfer the cargo, you need the berthing mechanism. Docking and berthing, there is only a difference that, and to do the berthing, we need to have the robotic developments, which is also one of the important requirement for the space station development. Even to establish a station, you need the robotic, and to transfer cargo, and to assist astronauts. And byproduct of this, we need this digital twin. If you take the space station development, you need to have the model in the for the crew to get trained, and then digital twin requirements, that is to simulation requirements. These are all the important new requirements for the space station development. In these areas also, we want the industrial participation to go ahead with the Bharatiya Antariksh station development. Now I'll just ask Abhijeet how we can contribute, whether avionics side, how they can contribute to the space station development, our space station development, Bharatiya Antariksh station. What way these aerospace can participate in our model, at least for BAS1 or during the course of development of the space station.
Surely, ma'am. Ma'am, thanks for giving that context for the technological challenges which we are seeing as the national mission is shaping up. So from all that you said, one of the addition which I would like to do is, the re-entry part. Even if once a BAS goes up, we have to focus a lot on like the space shuttle program, which, would do so many rounds, and that's how the ISS was set up. So our main focus right now as inbound aerospace is focusing on the solving of the re-entry challenge, which Muthu sir also said sometime back in the previous panel, is that we are working in-house, and there are other companies working parallelly to bring this re-entry technologies. We're talking of 2000 degrees centigrade plus. So our main focus right now is to solve that particular problem, and as and when there would be missions required to set up the BAS, we'll be supporting that mission with our re-entry technology. So that is one. And specifically about avionics, we are also working on the avionics for space planes, which once again was brought out previously, that it can do a lot of things more than just microgravity missions and commercial missions. We're talking of strategic level applications also. That's the avionics suite which we are building in-house, and we'll be happy to support whatever mission requirements come from the BS in the future.
Jay, regarding this, whether your docking system can be used for establishing our Bharatiya Antariksh station system directly, or whatever you are doing only for the refueling?
Sure, ma'am. I hope. Yeah. Yeah. So a lot to unpack there, ma'am. In the introduction, you brought out a lot of key areas where we can get involved. Maybe I'll start with one where we cannot get involved, the hygiene part. I keep hearing Group Captain Papa Naya saying that time and again, and there's no company making toilet for space. Sadly, yeah, so sadly that's not on our list, but for all the other items, docking, sure, definitely, like that is one of our key focus right now, where we can dock to satellites using just one camera and use that for relative navigation in tandem with other onboard sensors, but not necessarily using LiDARs or radars, which are typically used. So we're trying to get our AI and computer vision so ahead that we can just dock using cameras, and this will definitely be useful for, let's say, robotic arms on ISS, for BAS, for docking itself, as well as for robotic arms or free flying objects within the space station, which will assist the astronauts. And it is very important to have low swab there to be able to make these systems smaller and more effective. In terms of servicing as well, the ISS has like orbital replacement units which we can just swap out if something fails. So such infrastructure will be required for bigger satellites and BS. So it's on our list. And going ahead, like there was a NASA report in 2016 which said it's 100x cheaper to put a robot in space than a human to do certain tasks. And our goal as a company is to be able to make space robotics and assist BAS and other space stations to do so. If given a choice today, we would obviously always choose to work with a human in space, space station in space over satellites. But I think there are no opportunities. We would really appreciate, and we'll be watching out for more opportunities coming out of ISRO to be able to contribute and be part of this great mission.
Robotics is one of our major requirement. Once the BAS1 module is launched, there will be some time to the other module to get into dock. So before that, we want to send a cargo module so that it can dock, and whatever cargo is sent with robotic arm assistance, we want to do so. Definitely, if Aerospace is very much interested, then we can be a part of that, and already teams are working on that in UI mode and RFP mode. Then you can be part of that, and it will be a great requirement for ISRO also. Now I have a question to Chiranjeevi. He was doing these protection mechanisms. Now, whatever he is doing, how much it is relevant to BAS, how this company can contribute to BAS. And one of the requirement for BAS module is we should reduce the mass, because now the protection mechanism mass itself is almost equivalent to the structural mass. So now with LVM3 launch, the first module before the NGLV comes, we have to launch the BAS1 module with the existing our launch vehicle. So in this area, whether protection mechanisms, whether mass can be reduced, this part Chiranjeevi can.
Yeah, to give you context, ma'am is talking about orbital debris protection, micrometeoroid and orbital debris protection. See, typically any object about 10 centimeters is cataloged. So we regularly track them and we get alerts for these objects that there is going to be conjunction with your operational satellites. Either you have to move, or if it is a cooperative or if it is a friendly nation, you can ask that nation to move their satellite. That's how the collision avoidance maneuvers are taking place currently in space. Now, anything less than 10 centimeters, you need to protect your space station or your human space flight. That is going to be really challenging because you need to have thick micrometeoroid orbital debris protections on your satellite or your space station. Now what is going to happen in future is, now this 10 centimeter threshold is now coming down to 1 centimeter and even further down to 5 mm using space-based surveillance. We are going to put optical sensors in space, monitor these space objects and say that we can identify objects up to 5 mm or even 1 centimeter, even 1 centimeters. And then more number of alerts can be coming, and then you need not have that much thick protection on your satellite, but you can maneuver them or do a collision avoidance maneuver when such kind of conjunctions are happening. So that's going to happen in future. Still we need to get into advanced materials to reduce the mass of these protection systems. So as Cosmoserve, what we are building is building the solutions to remove the space debris. Now let's say there is a conjunction with your 10 centimeter satellite, but your space station is quite big. So every time there is an alert for 1 centimeter object coming or a 10 centimeter object coming, every time you moving your satellite is really tough because it will consume a lot of fuel. So that is when we can come into picture, we can remove those dead satellites. If, from the analysis from the Leo Labs data, it states that just remove 10 objects from space, 90% of your collision risk will come down. Because these 10 objects are so popular, they are coming regularly in your path, so you need to remove those objects. So we will be of help where such kind of objects are there and we can remove those dead satellites. Like I said, 1 year back I was sitting here without incorporating the company. Now 1 year on, our soft robotic capture system is at TRL 8, completed all the tests required to go to space, and we are in the launch pad integrating our system to the launch vehicle, and that system will go to space next month. And like he said, we are also working on vision-based navigation where we are at TRL 5. So primarily all our people sitting here are working on few technologies like rendezvous and proximity operations, vision-based navigation, docking, space robotics. All these systems are primarily going into under a bigger umbrella called in-orbit servicing, assembly and manufacturing. So the technologies, the applications, the use cases are different based on our company goals, but all these will go to in-orbit servicing, assembly and manufacturing. I think ma'am has brought a right point. Instead of we all aiming at in-orbit servicing, better we should aim at Bharatiya Antariksh station. So it is good for the nation and it is good for the company as well. So I take this point and we will focus our energy towards developing systems for Bharatiya Antariksh station.
Now for Aditya also, same question. How your this laser-based systems, how it is different from this Chiranjeevi's? He is also doing the space debris and you are also doing the space debris. Whether this can be used in our Bharatiya Antariksh station development, which you can elaborate.
Thank you. Yes, so we are in a part of active debris removal technology development, and what the Dr. Chiranjeevi is doing is mostly soft robotic systems. So first of all, a lot of people consider Orbital Laser and the other ADR company, we are a competitor. No, we are a collaborator. We provide payload to the Cosmoserve, suppose that Cosmoserve, and they can challenges like when the soft robotics system cannot capture a target which is uncontrolled, unprepared. So we slow down so they do not need a complex RPO, vision navigation system, and then they can easily capture, and like they don't need very complex robotic system, they just need a chopstick type. So that's what we are developing in orbital lasers. In context of BAS, so we are continuously studying because we are, first of all, I came as a scientific background. Now I'm a business lead towards orbital laser side. So I'll give you two contexts. BAS type companies also there in the private sector and commercial sectors. Russia launch, NASA launch, then the private company WAST, Axiom. A lot of companies are launching the space stations. The protection is two types. One is active protection, another is passive protection. So currently every space stations are using passive protection systems, which like ma'am explained that Dr. Chiranjeevi was doing previously in ISRO. So there is an active system also we can develop, that's called, we are developing. We study about laser system. So as normally 10 centimeter target we can detect using our object detection systems, navigation systems, and Leo Lab and other companies can detect, or in orbit system can detect. But if we have a laser system which we can put on the bus, multiple models, 360-degree protection for 100 to 200 meter distance, we can do it from a micro debris also. So we can notch them. So that's called active protection systems, which technology is not developed yet, but we are researching about it, and we are confident that in upcoming 7 to 8 years, we can provide this to the bus. When bus modules are upgrading, we will be the part of it. And that's where we are going to do it. This is the scientific side, and if I go for business side, so currently 2025, the total asset in the space which we need to be protected is $196 billion. 2026 is $230 billion. Suddenly it's like more than $30 billion was increased. So these activities increase the complexity, as Dr. Chiranjeevi was saying, that if we remove 10 satellites or 10 debris, we can protect a lot of space objects. So if we do not remove what happened on the global GDP context, so we are going to lose 0.5% every year till in 100 years. In 200 years, we are going to lose every year 2% of global GDP only on the space asset. But if we remove these 10 satellites or 10 objects or 10 debris or anything we remove, the complexity will decrease and will be governed approximately 0.6% over 100 years continuously. GDP will be growing. So space assets are very much important, both business points and scientific, technology, and industrialized side. So that's where we'll be coming towards. So I'm Indian. I built this company in Japan, but I'm really looking towards to be part of BAS project, so where we can put our lasers, and maybe we'll be having a good laser technology with the BAS.
Yes, welcome. Actually, we are waiting for many of this industrial participation for this bus development. Even now, whatever the procurement or the development, we are going in this industrial participation mode only. So you are always welcome. Now, question to Naresh. How your refueling technology, which can be used in our docking system, not like now you will have some technology for refueling between the satellites. Now during this part of this docking port and along with the Gaganyaan module, how this refueling technology can be used?
So, ma'am, earlier you mentioned capabilities like docking, refueling, berthing, and visual-based navigation. Robotic arms are critical capabilities required for BAS. So, similar to my earlier points on what we have done, I would like to go a little bit more on what we have learned from what we have achieved so far, and from what we are going to do, what are we going to learn. So, as I mentioned, we have done 2 microgravity experiments on parabolic flight. Our first mission was done in November 2024, where we demonstrated how in a microgravity experiment where there is a very little amount of gravity. So we've sent two modules. We try to understand how your algorithm should work, because when there will be a lot of perturbations in space and your camera have to adjust and you have to sense your target. Could it be an interface, or could it be any points of a satellite, how to accurately identify those markers. So we did a lot of algorithms testing. That's the first capability we validated. In the second microgravity experiment we conducted in the next 6 months, in the same parabolic flight, we had 3 different decks where we first understood how refueling works, because fluid dynamics, as you all know, in ground is very different from space. So we try to understand how bubble formation works, what pressure you have to give, what could be your viscosity. A lot of we try to understand, and we did a lot of data. We collected a lot of data. And the second part of the second microgravity experiment was to understand again how do you, in terms of avionics, how do you process the data on board, right? Because during docking and RP operations, you have to make decisions within a very short amount of time. So we did a lot of experimentation and demonstration on how you could structure your architecture of avionics. So that is the second demonstration that we did. And within the next 6 months, we launched IUSAT. It was India's first orbital refueling mission. Unfortunately, it did not reach orbit due to the PSLV, failure. But we did a lot of operational tests on how the docking interface could work, how the refueling works, how you could sort of automatically transfer fuel from one tank to the tank. So we did a lot of analysis on how refueling works. And the fourth one was we sort of opened India's largest private RPOD facility with ISRO chairman in inaugurating the facility. So we try to understand how your approach should work, how your GNC should work. So we have an epoxy floor where we could simulate two satellites. It could be a target, it could be a chaser. So we did a lot of understanding on how your approach could work. And so this is what we have achieved so far. And as I've said, with our next two satellites launching, so we will do an end-to-end RPOD, starting from long-range RPO, short-range RPO, docking, refueling, orbit raising, orbit lowering. So these capabilities could fit in the bars very succinctly or very perfectly, because we have done a step-by-step approach on how to validate these systems, and we know how to operate those systems, and we know how to apply those systems.
Thank you, Naresh. Apart from this BAS development, there are a lot of ground support requirements are there for BAS. Most of the things like when you take docking, there is a test facility development. This lot of ground support system development is one of the major requirement in the BAS development. I have mentioned only one thing, like this Chiranjeevi knows that MMOD, this high impact velocity testing, that is one of the requirement. Like this, if you take each and every system, lot of ground support requirements also is there for the BAS development. So in that also lot of industrial participations are required. So without that we will not be able to complete this testing, because before launching there are a lot of, actually to test a flight system we need a ground system which should be more reliable than the flight system. That is one of the requirement for all these developments. So in these also any of the participants who are interested can take part in this. That is one of the requirement. Thank you to all my team. And now one or two questions from the audience which can be asked to any of us.
So basically, we were talking about docking and orbital assembly, manufacturing, and servicing. Would a single coherent solution be preferable in terms of docking? Say, for example, in docking, we have multiple sensors that are being used. That takes up a lot of power, that takes up a lot of weight also. So, would a solution such that takes care of everything into one single component, would that be a helpful product that the space sector or ISRO could actually take up?
Can you introduce yourself before asking the question?
Sorry, sir.
So we can answer you according to your expertise.
Yeah. So my name is Amir Deshpande. I'm from Big Bang Boom Solutions, based in Chennai. We are basically a defense startup, but we are also getting into space and clean energy. So
now, to answer your question, so instead of having multiple sensors, so can we have a single sensor so that the power requirement, mass requirement, volume requirements are low? See, reliability and redundancy are two important terms in space missions, right? So reliability, you can do multiple tests, you can do all these things, but if that particular sensor, that one particular sensor fails, what next? So that is where we need to put in redundancy. And redundancy also, we have different types of redundancies in space missions. You have dissimilar redundancy. That is, if all the laser systems are failing, you need to have some other system. So that is called dissimilar redundancy. That's how to improve the redundancy. We will usually use multiple of these sensors, in particularly this kind of docking experiments where the stakes are really high and humans are involved. But there are standards with respect to the docking ports where we dock to each other. Those are really standardized things.
Those are standard.
But yeah, sensors, we need to have redundancy.
We actually do have, we have actually developed, we are in process of developing something that is actually going to replace multiple sensors into one actually. We are already at TRL6 and it does have triple redundancy also, multiple obviously.
Yeah.
But do you think this would be something that could actually help in even, interacting with both cooperative and non-cooperative payloads or debris or anything like that?
No, certainly, if that has an inbuilt redundancy. Again, each chain redundancy is not just the sensor redundancy.
Yes.
The entire chain till
Yes.
your OBC system should be independent.
Yes.
Otherwise, if one wire gets cut, your entire system will go, right? So we need to look into that. If that is independent, like we follow triple redundancy, etc. If that is in, then certainly there is a use.
All right.
Yeah.
All right.
Adding to his this one, mainly every system at least dual redundancy is built, and if you see control system and the critical avionics and other systems, triple redundancy is also built.
I want to add some international prospect towards this. So your question is very right now everybody is asking, is there a systems which we can have continuously and it will be interoperability and these things. So I'm also a part of a team from the ISO and AIIA and FCC site where we are understanding every type of from 1960s to how the development is starting from satellite and 1994 to 1996. One of the biggest company in the world is Northern Grumman. They perform using a space logistic company and they are developing the IPs towards development of capture berthing and docking system. So we really looking towards like your type of questions, and if you have these solutions, please give us so I can pass to the international audience and tell them that, see, India is also looking towards these systems and we can incorporate and make an interoperability task force where we can develop a technology which can be every company can use and every company can leverage the technology to develop the future like a BAS or Cosmoserve's docking systems, OrbitAID, Aules. So this is very much important. Thank you.
One more question.
Hi, this is Sai from Ground Zero Space. If it's a naive question, please ignore it. But I'm just trying to understand because there's a lot of technological development happening independently. So from interoperability side, I think some of it has been answered. But I think there's a global debate happening. It's like whoever gets first gets the pearl sort of situation in a lot of ways. So what is happening from the fundamental side of standardization? I'd like to know a bit more if something is happening along those lines. Like especially with docking modules, there's already been docking modules in some ways, but not in the way we require. So just like if someone can shed some light over it.
So there are two parts to this. One is if you see from a multilateral perspective, a lot of standardization process have been are developing independently. So a lot of companies are trying to reach out to each other and see if we can make it a standardized docking interface or a refueling interface. So for instance, if I want to service Cosmoserve satellite, if they want to service ours, there needs to be a standardized component between the both of us. So far there has been a lot of divergence approach, but things are moving slowly in multi-forum discussions like ISO or BIS, where people are trying to understand or starting to realize this system needs to be standardized. So with regards to OrbitAID, the interface that we have developed, it's about TRL9 since we launched 6 months back. It has a standardized design design, approach to its features, because we realized way back that this this interface is the standardized requirement. So things are moving slowly, but in the right direction, of course.
I'll just add to that. So in orbit servicing, like to have space sustainability, you need to remove the dead satellites. And another way is to ensure that the satellites are not reaching their end of life. That is by refueling, servicing, removing a dead battery. But currently the existing satellites don't have access to reach to these components which are dead inside. So you need to have such kind of satellite building innovation where every satellite is built in a certain way that most critical components will be placed very in an accessible location, so that other satellite can come and repair that particular component. So such kind of things are going on, but it is being discussed at ISO level and United Nations Office of Outer Space Activities, UN COPUS. So these things are coming up. So once all these things coming up, all satellites across the globe will be built in a certain fashion, and that is when space sustainability is possible.
Adding to this, if you see in BAS, this docking ring is IDSS compatible, so that other agencies can come and dock. So that level of now, when we are building now we are taking care with already existing satellites we cannot do. So further future, like Chiranjeevi said, all satellites will come into. But according to BAS, we are taking care of international collaboration also, having a common interfaces with respect to payload and with respect to docking.
Okay,
So
thank you.
one more thing is like when we're talking about international collaborations and development towards the policy development, how the government and scientific society can be work together. So one thing is like it takes too much time. You can develop a technology more faster than making a policy. Policy take decades of years, expertise, and continued collaborations. So we talk with OrbitAID what you are doing. Then they give us the points like we are doing these things. Then I pass to the ISO or BSI or BIS. Then the Cosmoserve, we talk. And then we do these continuously collaborations, and then we understand, okay, there is a point where the IPs are not matching or something. So like refueling, interface using your CAN or any type of RS-42 or something. Then the other problem is like after refueling, what the interface we are going to do is the thermal management. So how we are going to manage the thermal management passively, actively, and these types. So it will take time, and everyone is we are trying to build one synchronized IPs and based systems where everybody can leverage the technology. So the Cosmoserve and OrbitAID can together dock together. Together they can be serve as a mission profile also.
Just to add to it,
Final point? Yeah, sorry. I would like to add to what Aditya said, like with the last mission we worked with InSpace. So InSpace, as you know, is the mission authorizer. So since it was also India's first mission, and being a regulator, it was also their first mission to work with the private company on authorizing an ISA mission. So InSpace is also very open to having a discussion in terms of what standards would look like, what the mission profile should look like, because being a regulator, they should also keep in mind the sustainability aspect, the international collaboration aspect. So there is a lot of positive signals from the regulators in India. So I think it's going in a good direction. Yeah.
Thank you. Other questions we can take up later. Now already it's done.
A very warm thank you to our distinguished chair and esteemed panelists for an insightful discussion on the future of in-orbit servicing and space logistics. I would now like to request our chair and all the panelists to come forward for a group photograph. A huge round of applause, ladies and gentlemen, for our esteemed panelists. After concluding.